To me, this is just one of the most interesting engineering challenges of our time.
LLMs are the first time that AI isn't like hidden away under layers of computer.
Somebody said to me the other day, how does it summarize a document? And I said, well, nobody knows.
Hello world, and welcome to the Tech Overflow podcast. I'm Hannah Clayton-Langton, and today I'm without my co-host Hugh Williams, but that is for good reason. Those of you who tuned in to the early episodes of season 1 might remember that my whole motivation and inspiration for starting this podcast was that I wanted to learn about technology. I work for a tech company and I'm a technology user. I'm super interested, but I'm not an engineer. And when I reached for the resources to teach myself about tech, how it works, and to be better at my job, I couldn't find anything. And that's when I called up Hugh. So as Hugh's not here, before we get into it, let me just remind everyone of his pretty impressive CV in the tech space. Hugh started off his career in academia, but was quickly whisked off to the Silicon Valley and worked for the likes of Microsoft, Tinder, Google, and eBay, just to name a few. And so he's pretty well placed to tell us some industry secrets. This episode is all about the highlights of season 1. And I'm going to take you through some of my favorite moments, our best insider stories, technical insights, and special guests from season 1. So if you're enjoying the Tech Overflow podcast, please do like and subscribe wherever you get your podcasts. Share with your friends, family, colleagues, and you can find us on LinkedIn, Instagram, and X. Season 2 is coming to you on the 3rd of March, so mark your calendars and we'll see you there. And now for the good stuff. So I've put together some segments in this episode to share some of the best bits and my favourite moments from season 1. I hope you enjoy. Moment 1 was when we deep dived into the CrowdStrike disaster. So that was episode 4. Hugh and I talk about what actually happened, what went wrong, and why this was the biggest outage in the history of tech at the time of recording.
So it opened up the file, it found it had 21 fields, the software was expecting 20, and all sorts of bad things started to happen.
And so because it's so deeply embedded, it wasn't just like error, please restart, or error, couldn't read file type. You ended up sort of tripping the whole system. And blue screen of death, right, means can't use your computer. Like, that's
right.
it.
Exactly. Because if something like Word had a problem like this, Word would crash.
Yeah.
And you'd say, Word's crashed. I'll try starting it again. It keeps crashing. Maybe I'll try downloading a new version, or I'll wait till tomorrow till Microsoft updates it. But because this Falcon software runs deep inside the operating system, it actually took down the operating system, this error. And so all these blue screens of death started happening. So CrowdStrike folks deploy this file and they basically shut down every Windows machine that this software is installed on. They all get the blue screen of death. Of course, what happens after the blue screen of death is a lot of folks will try and reboot the machine.
Yeah.
So they say, reboot. But the problem was when it booted back up, the same thing happened again.
And every Windows system across the world that had Falcon installed basically went black or went blue.
And was unusable and would not boot up again.
Moment 2 was a real interesting one as a British shopper. So this was all about Marks and Spencer's, or M&S. They had an absolutely massive hack through 2025. Took them out for well over a month. And the most interesting bit was that Hugh's take slightly differed from what is on public record. So have a listen to what we think likely actually happened.
So I think M&S issued some official communication that they caught this whole hack pretty early days, but I think that's been somewhat debunked.
Yeah, I don't think that's true. I think what is true is that once the ransomware was executed, and we'll talk about ransomware and what it does a little bit later on, once that was executed, M&S were very quick to explain that that's what happened and begin a path that took a long time towards rectification. But I don't think they were quick to detect that the hackers were inside their systems. And some folks are saying they're probably in there at least a couple of months.
We can talk later about whether or not that's unusual. I think the answer is no.
Not unusual.
No. Okay. So hackers, they get in, they exploit this vulnerability, and then they do like a few really key things that sort of set them up for success in taking things down.
Yeah, that's right. I think there's a couple of parts of the story that we'll never know the real details to, but what certainly happened is they got in as fairly low-level employees, right, or contractors. They've now got access to some system. It's certainly not going to be the absolute core of M&S. But they're in the edges. They've made it into some of the outbuildings, if you wanted to use an analogy. Somewhere along this track over the next couple of months, they've managed to what we call escalate their privileges. So they've managed to figure out how to get more access to, more of the buildings, to continue the analogy.
And our last little snippet, I think, is just the perfect example of good product management in action. So when Hugh ran Google Maps from, I think it was 2015 to 2017, he talks about some competitor research he used to do on his drive to work.
I was lucky enough at the end of my executive career in the US to run Google Maps. So I looked after the product and engineering teams for Google Maps. And I can tell you that I quite often used to drive to work using Apple Maps.
But you were doing that just to know
they
hadn't changed their game or come up with anything.
Yeah,
super useful.
and I had a lot of respect for them. I knew they were trying really, really hard. They had a catastrophic launch in 2012, and this is more like 2015 when I was using it. So they'd really got off their knees and kept on going. And they were beginning to do some pretty useful things. Like, I'll give you a couple of examples, actually. They were the first ones to have a parking feature. So when you parked your car, they'd put a pin on the map that showed where you parked your car. Fantastic feature. So I remember going into Google and saying, hey, Apple's got this awesome feature. One of the product managers said, oh, yeah, we've got that kind of queued up in our list. And I said, well, probably time we put that towards the front and got on with that. And, ultimately Google released that, I think probably 6 or 7 months later than Apple. But I thought it was a great feature.
Okay, so now I'm going to run you through our top AI moments through season 1. The AI insights that I took away from season 1 are probably the things that have most shifted my mindset about how technology works. And AI is going to be a huge focus of season 2 at listener request. So we're super excited to get into more detail there. Just as a little reminder, Hugh worked in AI from the early 2000s at the likes of Microsoft, eBay, and Google. So he helped with some of their AI tech, which if you haven't listened to our episode in more detail, you'll learn that AI has been around a little bit longer than people might think. And in this next segment, Hugh and I talk about large language models, or LLMs. So that's the likes of ChatGPT, and how ubiquitous they are in terms of daily users globally.
AI is something that folks like me have been doing for 20, 25 years behind the scenes in large tech companies. So this whole idea isn't very new to me and to lots of people like me. But now the whole world can use AI in a consumer kind of way. So you can download an app, you can get it on your phone, you can pull it out of your pocket, and you can actually kind of talk to it and reason with it. And that's a massive breakthrough. I think that's a little bit like the iPhone, if you like. So, back in the day, computers were big things that were stored in rooms, and then some people had one at home that was on a desk, and then boom, this revolution happened, and now everybody has one in their pocket. I think that's exactly what's happened here. Is AI has now become a product that's used by consumers, and then it's obviously swept the world.
I think my favorite episode of the whole first series was episode 7, actually. And that's where Hugh and I discuss how LLMs are trained. And we talk about the massive scale of building them. And there's some pretty cool stats that bring that to life.
The scale of LLMs is just so incredibly different. I mean, I'll use the word token a little bit later on, but you can just think words for now. These LLMs are trained on hundreds of billions or maybe even trillions of words to be able to generate the text that they generate. I've heard estimates that say that OpenAI's latest GPT-4, so the ChatGPT that you're using today, was trained on about 13 trillion tokens, about 9 trillion words.
And probably the most compelling thing about ChatGPT and its peers, as we know, is how they produce output that feels like cognizant and human-like. In episode 7, Hugh shares that no one actually knows how this works, and it's part of their magic, and I don't use that word lightly. They're basically built with a technology that learns from so much data that it can output plausible text based on any input you give them. And in this clip from episode 7, Hugh talks about how LLMs summarize text.
Somebody said to me the other day, how does it summarize a document? And I said, well, nobody knows, really. So when you say, please shorten this document or summarize this document or turn this document into bullet points, it's just seen enough of examples of that in the vast amount of text that it's seen that it's able to carry out that task, right? So it's seen examples of a long document shortened to a shorter document. It's seen an example of an essay turned into PowerPoint slides, whatever it is. It's seen enough examples of that in the trillions of words that it's seen that it's able to do that. So you give it a simple instruction like summarize or shorten, and it can take the following content and know what to do with it.
And the final piece of the LLM puzzle, which I particularly loved, was all about how they're trained and how they use GPUs, which is those chips that everyone's talking about, that companies like NVIDIA make. Now, I've heard a lot about chips, GPUs, and NVIDIA, but I hadn't quite understood how they fit into the overall LLM story.
So you have a bunch of GPUs, which costs like 40 grand or something.
Yeah, of that order.
In USD.
Yeah, absolutely. So, 20 to 40,000 bucks per GPU card. And, these data centers are absolutely full of them for this training process.
Just for the training process?
Yeah, they're using the evaluation as well. So when you want to buy your holiday to Florence or whatever it is that you're asking about, or help me cook a recipe or whatever, those kinds of things, the GPUs are used in that as well. But you need vastly more infrastructure for the training than you do for the inference, which is the what we'd call the question asking piece of this.
Okay, because there is a whole topic of conversation around like the compute power required by LLMs and like the environmental cost of it and the financial cost of it, but the main consumption of that compute happens in the training phase.
Correct.
Okay.
So training takes weeks or months, probably costs $50 to $100 million to do. When you type a question like, help me plan my itinerary to Florence, that probably costs a very small fraction of a cent.
So we loved our interviews in season 1, and we know you guys did too. We had 2 special guests, and we're having even more joining us in season 3 that you'll love, but no spoilers. So first up, we had Jonathan Badeen, who is the co-founder of Tinder and the inventor of the famous swipe right, which changed the landscape of modern dating. Jonathan opens by telling us about Hatch Labs and shares how the app actually got the name Tinder.
So the original Matchbox was to be an app. It never really existed. Because Hatch Labs' focus was actually on creating disruptive mobile apps, so native mobile apps and all. And so that was the focus. And then, of course, Tinder, when we were making Tinder, we were going to call it Matchbox, but because of issues that could arise with Match.com and all, started looking for different ways of different names and all. And Tinder was one of those, kind of went along with the fire theme that we were kind of going with. And so we ended up ultimately landing on Tinder.
Tinder was also famously the first dating app. And here Jonathan talks about some of the decision-making behind the scenes that were really smartphone-centric for the first time and how that led to truly revolutionary user experience.
But there were a lot of decisions that got made because of the platform. Obviously, your swipe couldn't exist without gesture technology, which comes from a touch screen. We originally had sort of the quick and easy way to log in or to create an account because you don't want to be typing profile for an hour on a small little, so Facebook login, which was more of a thing then than it is now. But it allowed us to create these profiles real easy. We crafted the communication part of it more off of texting as opposed to the previous things, which were more email centric. You got this small screen, you're going to put less information about the person right up front. And so the very first version had a photo, although not quite as large as it ultimately ended up becoming, first name, age, and it had a number of shared friends and shared interests. And then you tap into the profile and you could get all of that plus a little written blurb. But, I think it's a lot of people think, oh, it's only photos. Never was only photos. However, it does turn out to be actually one of the most important things.
We had to ask Jonathan about how he invented the swipe right. And he shared a really insightful story about how flashcards were the real inspiration behind the way that he built the swipe right on our smartphone screens.
I woke up one morning with this epiphany, just like literally woke up and just got really excited about how I thought you would make the perfect flashcards app. And that was, you would swipe in one direction for flipping the card over and you'd make an actually good swipe. But then you'd swipe in the other directions for saying, I got the card right or I got the card wrong. And I kind of came up with this with the idea of like how I would use real flashcards, like in real life. Not going to class, but like if I was sitting there, I'd start out with a stack of cards and I would take that card and I'd put it into one pile if I got it right. And that's the cards I don't need to study anymore. I got this one wrong. I'm going to put it over here into this other pile. It's the one that I need to study more. And so now you got 3 piles of cards until you whittle it down to 2. And so I envisioned those 2 stacks of cards, the right and the wrong ones, right off the screen of the iPhone because your screen's small, right? And basically, that's where the gesture comes from, is dragging that card to the wrong or right stack that's just off screen. So ultimately, when we ended up making Tinder, we had already landed on this sort of one at a time sort of card.
Our second interviewee was Nick Pelly, Director of Engineering at Waymo. We were really lucky to have him join what was our most listened to episode from season 1. Nick shares why users and riders love Waymo, why they're actually safer than human-driven cars, and how they're expanding across the globe. They're actually coming to London, and I'm really waiting to jump in my first Waymo. So in this next clip, Nick explains to us in his own words exactly what Waymo is.
Let me describe what Waymo is. It's a robotaxi experience where, you pull out your phone, hail a vehicle, much like you would do with Uber. In fact, in some places we partner with Uber, and the vehicle comes to pick you up. But in this case, the vehicle is empty. It's going to pull over on the side of the road with no one inside. You get a private vehicle, a private experience, and it's going to fully autonomously drive you to your destination. So this is a ride-hailing service. It's what in the industry we describe as level 4 autonomy. If you like later, we can get into some of those different levels. The level 4 meaning, there is no human in the vehicle that is ready to take control of the steering wheel. There's no one in the vehicle who needs a driver's license.
And if, like most people, you're concerned about the safety of robotaxis, let's join Nick in discussing what the data shows about the safety of autonomous vehicles versus human-driven cars, and how that debunks the myth that they might be in any way less safe.
That's the most noticeable for the user is you get a private experience, and that's a really big win. But what we think a lot about is the 40,000 road deaths, just in the US, 40,000 road deaths per year that are completely avoidable. And the safety benefits that an autonomous vehicle bring are quite dramatic. We've now driven over 100 million fully autonomous miles, and we've looked back at that data, and we have between 5 and 10x less accidents than human drivers who are driving in the same geographies. The safety benefit is really quite stark.
One thing that I took away from this episode is that Nick really loves his job and the challenges it brings to him as problems to solve. So there's a lot of hardware involved, and I learned some new words in this episode: radar, LiDAR, and other sort of sensors on the car. But here's Nick talking about the breadth of the software challenges that Waymo have to solve as well.
This is just one of the most interesting engineering challenges of our time because of the complexity, but the breadth of engineering involved. And I've touched on some of the hardware side of things, but also on the software side, we have these real-time safety critical systems on the vehicle, as well as rider experience and user interface systems in the vehicle. Then we have the mobile app, and we have a lot happening in the cloud. There's both the sort of ride-hailing system that you can think about matching demand and supply and having a efficient marketplace there, much like other ride-hailing companies do. But then also the simulation systems and the log replay and the ability to visualize and play back what's happened in the field. There's such a rich ecosystem of tooling and infrastructure off the vehicle as well. I don't know if I've ever worked on a project with such a span of different software systems. It kind of brings every single software discipline together, as well as many different hardware disciplines.
So clearly the world is changing as autonomous vehicles are becoming more and more common. And here is Nick sharing a little bit more about what the future could look like in a world of autonomous vehicles.
This is going to take a little longer for all the impacts to play out, because we're talking about city design, we're talking about manufacturing of much larger objects, we're talking about a safety critical system that has a lot of engagement with regulators as well. But this is the direction. It won't just be ride hailing, it'll be personal car ownership, it'll be trucking, it'll be all forms of transportation over time. You could imagine some quite high percentage of cities right now is dedicated to vehicles, and especially to parking. I believe it's in the 30 to 40% range. If you look at a city by real estate, is dedicated to parking.
Wow.
And with autonomous vehicles, better utilization of the vehicles, so there's less parking. And when you do need to park them, you can easily move them outside of the city. So what this will mean for how cities are laid out and real estate is quite dramatic, and this will be significant. Also to people's lives, I think this will make the world feel smaller, much like the jet plane did or the automobile did originally. It'll become easier to get from A to B because you can use that time much more productively, and you can know you're getting there much more safely. And I'm sure over time we'll see a sort of abundance of options. You could imagine autonomous vehicles that have beds that you can sleep in. I don't know what timeline that is on, but that's clearly, where we're going, that you can work, you could play, you could sleep, in these cities and just make the world feel smaller.
And last but not least, listener questions and the controversial tech trivia. So in our last episode of the season, we took some listener questions. Thank you to all of you who sent those in. And here is Hugh getting into some acronyms.
LAN is local area network. So, if you're in a building, you've got Wi-Fi, you've got some cables running around the building, could be your house, could be where you work, that would be called a LAN. So it's basically the network that is within your building. And then a wide area network is, the bigger version of that, right? So that's something that a company might use to connect two campuses together. Or, you've got some infrastructure out in the field somewhere and you want that connected back to the head office, then that would be a wide area network that you'd be using to connect all of your infrastructure together. So folks like Google, Amazon, those kinds of folks have very, very large, sophisticated WANs that connect together all their infrastructure, including all of their data centers, warehouses, offices, all these kinds of things are all connected together on a giant network that you'd call a WAN.
One thing I learned was that Hugh has spent a lot of time in massive data centers, which I have to say is not something I've thought about much until they've hit the news a fair bit quite recently.
I might share a couple of pictures on socials of me walking around data centers with some big data center infrastructure from the old days. Lots of blinking lights, cables, really cold fluorescent lights. They're gigantic pieces of infrastructure. I mean, they're some of the biggest warehouses you will ever see, just completely filled with computers. It's very, very cool.
Interesting. And they're like in random places where there's like loads of land available, right?
Yeah. And you might put it next to a hydropower station or somewhere where there's a lot of solar available, or perhaps, nuclear energy or whatever it is, because they do use a lot of power to run the infrastructure and keep the infrastructure cool, because, all of these CPUs and GPUs get very, very hot, and so you need a lot of cooling. And so, put them next to rivers and pump cold water through them, all sorts of interesting things. So they're in very interesting locations, often hard to get to.
And our last moment takes us back to our very first episode. Hugh and I were super nervous trying to figure out how to be podcasters. And we learned something really interesting about how engineers that know some of the super old coding languages can actually make some pretty good money helping companies out.
So, for example, there's a coding language called COBOL. It was very popular in the 1970s. It's one of the most verbose coding languages, so it takes lots and lots of lines of code to get anything done. And you can get paid an enormous amount if you are a COBOL programmer today, because lots of big banks, insurance companies, these kinds of folks, telecommunications companies are still running COBOL systems. I said I was in Thailand last week. I was talking to a bank executive, and most of their systems are still COBOL systems running on giant mainframe computers that they maintain themselves. And so if you're capable of writing code in COBOL, you can get paid very, very well. And that's probably not true for Voyager 1 and Voyager 2, because they're probably really exciting jobs to have. They probably don't have to overpay for those. But knowing historic programming languages turns out to be valuable.
So that's a wrap on the best bits of season 1. Hugh and I had a ton of fun putting it together for you, and season 2 is coming soon with our first episode out the 3rd of March. So we'll have a trailer out for season 2 in a couple of weeks, and I am really excited about some of the guests we have lined up, but I won't share any more just now. Please do like, follow, review the podcast, share it with your friends, colleagues, family, and Hugh and I will be back soon. We can't wait to see you. Bye.